Good morning, students. In today's class we will discuss some more concepts of parabola. Already I made 2 videos on concept of parabola. So this is third part. In this class we will discuss some more concepts. First of all, notations. In this chapter we will adopt some notations. Already we have seen notations in the chapter circle. So similarly, if a parabola is given, for example, if what is parabola's standard form, y square is equal to 4ax. So in this video we will discuss some concepts of parabola by taking the parabola y square equal to 4ax. There are many forms of parabola, but in the discussion of tangent, normal, etc., we will take the first parabola y square equal to 4ax and discuss. If you want the same concepts for other, you can proceed in the similar way. So what is the parabola y square equal to 4ax? So y square equal to 4ax can be written as y square minus 4ax equal to 0. So in this equation, if I denote this y square equal to 4ax by s, if s is equal to this, then we will adopt some notations. Then for this curve, this equation, what is s1? Writing notations is very important. So what is s1? Y square means y into y. There is one index, no? Write 1. Next 4ax. This can be 2a into x plus x1. One index is there, so you put index for 1x. So if s is equal to this, then s1 is this. Similarly, you can write many notations. s2. What is s2? y2. Index is 2 here. Minus 2a into x plus x2. s11. There are 2 indexes. That means for both you will get 1, 1. So y1 means it is nothing but y1 square. Here also you should write x1 because there are 2 indexes. x1 plus x1, 2x1 into 2a. What it is? 4a x1 only. If you want s12, there are 2 different indexes. Therefore you should write y1, y2 minus 2a into x1 plus x2, etc. These are the notations which we will use in this chapter. Yes. Next, position of a point with respect to a parabola. So in circles we have seen, if a point is given, there arises 3 chances. Point may lie outside the circle, on the circle, or inside the circle. Similarly, here we will see the position of a point. Position of a point. Position of a point with respect to a parabola. With respect to a parabola. We will discuss this. So, position of a point with respect to a parabola. We should take a parabola and a point. Therefore, I shall take a parabola. Y square is equal to 4ax. Be a parabola. Be a parabola, and I will take a point in the plane. Let capital P x1 comma y1 be any point in the plane. Yes. So here now we are discussing the position of a parabola, position of a point with respect to a parabola. If a parabola and a point are given, how many different chances will be arising? So here what is the parabola? Y square equal to 4ax. We know the nature of this curve. So this is the parabola y square equal to 4ax, whose axis is x-axis and vertex is 0, 0, and tangent at the vertex is y-axis. Yes, this is the parabola. It is an open curve. If a point lies here, then the point is said to be interior point. If it lies outside this, then the point is said to be exterior point. If point lies here on the curve, then the point is said to be on the curve. Now let us see. So here I will denote the parabola by S. So what is S? S is equal to y square minus 4ax equal to 0. This is the parabola. And a point capital P x1 y1 is taken, no? It is any point. So if the point P lies here, this is point P in the plane. Now we will discuss the different chances. I will draw a perpendicular from P to x-axis, that is axis of the parabola. Draw a perpendicular. This perpendicular is intersecting, meeting the parabola at Q. So this point Q will have same x coordinate, because for P and Q x coordinate is same, but y coordinates are different. Its y coordinate is y1, that means this distance is y1. For this point capital Q, only this will be the y coordinate. We will suppose it is some y naught. So therefore, now the point capital Q x1 comma y naught lies on the parabola. Lies on the parabola y square equal to 4ax. If a point lies on a curve, it has to satisfy the equation. Substitute y naught square is equal to 4ax1. Say equation number 1. Now we will see the different chances. The point P lies outside, carefully, outside or on or inside the parabola, according as see what is this? This is the point at the moment here it is outside the parabola. When it lies outside the parabola, what is this? This is y1 will be greater than y naught. See, this distance is y naught, y coordinate of this point, and this distance is y1, y coordinate of this point. If point P lies outside, then y1 will be greater than y naught. y1 will be greater than y naught. For example, if P lies on the parabola, when P lies here, y1 and y naught will be equal. So I wrote here P lies firstly outside, then on, then inside. When it lies here, Q1, y coordinates of both the points will be same, therefore they are equal. If P lies inside the parabola, then this will be the y1 and this is y naught. In this case, y1 will be less than y naught. These are the conditions. So let us obtain a formula here. Now squaring both sides, y1 square greater than or equal to or less than y naught square. So this implies, so what we have, y1 square greater than or equal to or less than. From equation 1, what is y naught square? It is 4ax1. So this implies y1 square minus 4ax1. I wrote it on left side 0. What is this? Y1 square minus 4ax1. So we have denoted the curve by S, no? For this curve, this will be S11. So S11 greater than or equal to or less than 0. So in this equation, what is first one greater than? So the curve will be, the point will lie outside the parabola when S11 greater than 0. Second one, point will lie on the curve if S11 equal to 0. Point lies inside the parabola when S11 less than 0. That's all. This is the discussion of position of a point with respect to a parabola. If a point is given, what we should do? We should find S11. If you get S11 greater than 0, then capital P, x1, y1 point lies outside the curve, outside the parabola. If you get S11 is equal to 0, then the point P lies on the parabola. If S11 is less than 0, then the point P lies inside the parabola. That's all. What is this concept? It is 100% same as the circles. In circles also, if a point is given and a circle is given, to know its position, we should find S11 there also. If S11 is greater than 0, point lies outside. In circle also same concept. If S11 equal to 0, P lies on the curve. S11 less than 0, P lies inside the curve. Yes. Next concept, the equation of a tangent to the parabola at a given point. Listen now. The equation of the tangent, to the parabola y square equal to 4ax. I denote the curve by S. I can write S is equal to y square minus 4ax. At the point x1 comma y1. So the equation of the tangent to the curve y square equal to 4ax denoted by S at the point x1 y1 is, what is the tangent at the point? S1 equal to 0. You please recall, in circles also, equation of the tangent at a point on the circle is S1 only. Further, in ellipse, hyperbola also same. For any curve, tangent at the point is on the curve. Tangent at the point for all the curves is S1 equal to 0. Okay, let us see the proof for this. So here y square equal to 4ax, a curve is given, we know the nature, it will be like this. We are finding the equation of a tangent to equation of the tangent to this parabola at the point. This word is important. At the point means point is on the curve. At the point means there exists only one. If point is outside, then we say tangents from the point. From the point means there exist two. If point is inside, no tangent will exist. So this word is important. Tangent at the point x1 y1. That means we are finding the equation of the tangent to the curve, to the parabola y square equal to 4ax at the point x1 y1. So this is the tangent line. So now we will find this. We will show it is S1 equal to 0. So first of all, we are finding tangent at a point on the curve. That means see its proof. Here the point x1 comma y1 is a point on the parabola. Point on the parabola y square equal to 4ax, or you can write s is equal to y square minus 4ax is equal to 0. Therefore, just now we have seen about the position of a point with respect to a curve. If point lies on the curve, then what will be the condition? S11 is equal to 0. Yes, equation number 1. Now let us try to find the equation of this tangent. What is a tangent? It is a line only. This line passes through x1, y1. x1, y1, actually it is a point on the curve, but at that point only we are finding tangent. That means tangent also passes through this. With one point we cannot find the line's equation. We need another point or slope. So another point is difficult. Therefore we will try to find the slope of the tangent. In calculus we have a chapter, tangents and normals. If you differentiate a curve and if you obtain dy by dx, from that dy by dx you can write the slope of the tangent at given point. So taking the curve, I will differentiate with respect to x. If I differentiate with respect to x, this is 2y into dy by dx. We are differentiating with respect to x. 4a into x derivative is 1. Therefore, dy by dx is equal to 2 can be cut 2 times. Therefore, 2a by y. What is this? This is dy by dx. For a given curve, there will be only one dy by dx. But there will be many tangents, infinite tangents. This dy by dx will not give us a slope of the tangent. From this you can obtain the slope by putting the point in that. Wherever you want a tangent, you are supposed to put the point in this, then that quantity, that real number will give us slope of the tangent. Yes. So the slope of the tangent at the point capital P x1 comma y1 is, that is dy by dx value at x1 y1. This will be 2a by y1. Yes, this is the slope of the tangent. Now for this tangent we have a point and slope, no? Therefore using point slope form we can write the equation of the tangent. Therefore the equation of the tangent at the point, this word at the point is important. At the point x1 comma y1 is, using point slope form, y minus y1 is equal to m into x minus x1. We will substitute values. Here point is x1 y1 only. We have what? Slope is 2a by y1 into x minus x1. So this is the tangent. To remember the formulae simply or easily, we will be transforming those into notations. Yes, let us simplify. By cross multiplication, y1 minus y1 square. On the right side 2ax minus 2ax1. And I arrange this as y1 minus 2ax. I wrote this on left side. y1 square minus 2ax1. Why I am doing this? Simply because to get the equation in notations. Okay. So for the curve y square equal to 4ax or s equal to y square minus 4ax, what is s1 for this? S1 is y1 minus 2a into x plus x1. We know this. What does it mean? It is yy1 minus 2ax minus 2ax1. So here we obtained yy1 and minus 2ax only. This term is missing, no? Therefore adding minus 2ax1 on both sides. Then this becomes 2ax. We are adding minus 2ax1 on both sides. Here also minus 2ax1. Now this left side quantity becomes yy1. Taking minus 2a common, we will have x plus x1. On the right side, y1 square minus 2ax1 minus 2ax1 minus 4ax1. For the given curve, which curve? This curve. S is equal to this. For this curve, what is left side expression? It is S1. Right side one is S11. But we are finding the tangent at the point. Therefore, point is on the curve. When point is on the curve, S11 is 0. Therefore, from equation 1, this becomes 0. So from equation 1, S11 is 0, therefore we will have S1 equal to 0. This is the equation of the tangent to the parabola S equal to 0 at the point. This word is important now. At the point only there exists one tangent. Equation of the tangent at the point x1 y1 to the parabola S equal to 0 is simply S1 equal to 0. Already seen in the circles. For circles also tangent at the point is S1. For further ellipse, hyperbola in those chapters also, for those curves also tangent at the point is S1 equal to 0. Yes. After finding tangent at the point, we will discuss one more concept. What is that concept? The condition for the line, y is equal to mx plus c to touch the parabola. Y square is equal to 4ax. Yes. Now we will discuss this concept. The condition for the line, or condition that the line to touch the parabola y square equal to 4ax. In circles, if a circle and line are given, the condition for the line to touch the circle D is equal to R. Similarly, we will obtain a condition here. See carefully, here a parabola is given, y square equal to 4ax. We are discussing all these concepts, tangent, normal, condition of tangency, everything by taking the parabola y square equal to 4ax. But there are many different forms. It takes time to discuss for all those parabolas, different forms separately. It takes time. Therefore, we will discuss for this parabola only. In the problems, if some other parabola is given, then you extend the same concept to those also. Yes. So here a parabola is given and a line is given. Condition for this line to touch the parabola. See now. Condition for this given line to touch the parabola. A line touches a parabola means it touches at a point, at some point. So we will suppose the line is touching at x1 comma y1. This one is important concept. See now. So I will suppose Let the given line y is equal to mx plus c. Say equation number 1 touches the parabola y square equal to 4ax, that is s equal to y square minus 4ax equal to 0. I am supposing that this line is touching at x1, y1. A line is touching a curve means it has to touch at one point. We have taken the line is touching the parabola at x1, y1. Okay, this is the given line. Now what the line is? Now the line is a tangent to the given parabola at the point x1, y1. Yes. Now what I write? But the equation of the tangent to the parabola to the curve s equal to 0 at the point x1 comma y1. Just now we have seen for the parabola s equal to 0, tangent at the point is what? s1 equal to 0. Watching the curve, I will write s1. What is it? y1 minus 2a into x plus x1 is equal to 0. So I will arrange this as y1 equal to 2ax plus 2ax1. This is equation number 2. Now you please see. Is there any relation between equations 1 and 2? What is 1? 1 is the given line, and we have supposed that the line 1 is touching the parabola at x1, y1. That means it is a tangent to the parabola at x1, y1. What about 2? This is also tangent to the same curve at same point. Therefore, equations 1 and 2 represent the same line. Therefore, equations 1 and 2 represent the same line. They represent same line. Since equation 1 and equation 2 represent the same line, ratio of the coefficient should be same. Here you take this. Here y term is on left side, whose coefficient is y1. Here also y term is on left side, whose coefficient is 1. Similarly, x term is on right side, whose coefficient is 2x. Here also it is on right side, whose coefficient is m. Here the constant is on right side, which is 2ax1. Here also constant is on right side, which is c. So from this I will separate x1 value, y1 value. That is, I am finding the point of contact. If you want x1, take this and this. 2a can be cancelled, c comes here, so x1 will be c by m. y1 is this, y1 by 1 equal to this, that means y1 is 2a by m. This is the point x1, y1 where the given line is touching the parabola. What about this point? This point is on the parabola as well as on the line. It lies on both. It satisfies both. Therefore, I will substitute this point in the equation of the parabola. You can also substitute in the line because it satisfies both. This is x1, y1, this one. So y square, what is y square? 4a square by m square is equal to 4a into x. What is x? c by m. So I can cut 4 and 1a and a, of course m and m. What is there on the right side? We have only c. On the left side we have a by m. Yes, therefore the condition for the line, most important one, the condition for the line y is equal to mx plus c. The condition for this line to touch the parabola parabola y square equal to 4ax. What is the condition? Condition is c is equal to a by m. Yes. And the point of contact. This line is touching the parabola. It will touch the parabola when c is equal to a by m. Okay, we will add some more concepts here. You please see note. We will write some important notes here. Please see note number 1. So what is the line here? This is the line y is equal to mx plus c. This line will touch the parabola if c value is equal to a by m. So I will substitute c value here. What is c? A by m. When c is a by m, already this line will be a tangent to the parabola. Therefore, this equation y is equal to mx plus a by m is a tangent to the parabola, which is known as tangent in the slope form. Listen carefully. The equation of the tangent to the parabola y square is equal to 4ax in the slope form. In the slope form is most important. These are very useful formulas. Y is equal to mx plus a by m. Equation of the tangent in the slope form. And the point of contact of this is, and the point of contact, and the point of contact, that means where this line is touching the parabola. What is the point of contact? x1 y1 is point of contact, which is in here c by m comma 2a by m. This is the point of contact. So in place of c, again still you can write a by m here. If you write c is equal to a by m, this becomes am square comma 2a by m. This will be the point of contact. And the point of contact is a by m square comma 2a by m. Yes. So here just now we have discussed. What is this discussion? Most important one. The line y is equal to mx plus c touches the parabola y square equal to 4ax if c is equal to a by m. This is one concept. And for the parabola y square equal to 4ax, this line will represent a tangent, which is known as tangent in the slope form, and this is the point of contact. So when point on the curve is given, if a parabola is given, if a point is given x1, y1, see the difference. Then equation of this tangent is what? S1 equal to 0. S1 equal to 0 is also tangent, no confusion. S1 when you should use S1 equal to 0, S1 equal to 0 should be used when a point is given. When a point is given on the curve, tangent at that point is S1 equal to 0. This is applicable for all. Wherever if point is not, generally if point is not given, we will take this y is equal to mx plus a by m. This tangent is tangent at the point, should be applicable when point is given. For the remaining cases, this can be taken as a tangent, which is known as tangent in the slope form, and this is the point of contact. Yes. After that we will see another important concept, an important result. See carefully. See now, a parabola is given y square is equal to 4ax and a point is given Say, we know that this is the parabola. A point is given x1, y1, which is external point. When point is external point, we can draw two tangents to the parabola. These are the two tangents. When point lies on the curve, only one. When point lies outside, two tangents can be drawn. These are the two tangents. That means they are two lines. Since they are lines, they will have slopes, no? Let slope of first line is m1 and the second line is m2. Then we have some beautiful properties. Point number 1. Here what about m1, m2? m1, m2 are slopes of the tangents drawn from x1, y1 to the parabola y square equal to 4ax. The equation of the curve is y square is equal to 4ax. Then we have some conditions. What conditions? Sum of the slopes m1 plus m2. This is y1 by x1. Next, number 2. Product of the slopes m1 m2. This is a divided by x1. Very useful in objective. These are the values of m1 plus m2 and m1 m2. Yes. Also we have one more. So I am not looking into the proofs. Of course they are simple only. These are the two tangents drawn from an external point. If angle between these two tangents is theta, how to calculate theta? We have a formula for that. If m1, m2 are slopes of two tangents and theta is angle between them, then tan theta is root over s11. Root over s11 divided by mod x1 plus a. Using this, you can find the angle between the tangents. Angle between the tangents. So, a parabola y square equal to 4ax is a parabola from external point. Very simple. We can draw two tangents. They will have two different slopes. Say they are m1, m2. Then the relation between m1 and m2, their sum is y1 by x1. Product is a by x1. If theta is angle between them, then tan theta equal to root over s11 by mod of x1 plus a. Yes. For the parabola we have seen. Listen now. For the parabola y square equal to 4ax. For this parabola, listen. If a line y is equal to mx plus c. For this parabola, this line y equal to mx plus c touches the parabola when c is equal to a by m. Just now we have seen, we have discussed this. This is the condition for tangency. The line y equal to mx plus c touches this parabola when c equal to a by m, and the point of contact in this case, and the point of contact is a by m square comma 2a by m. Yes. Condition is c equal to a by m and point of contact is a by m square comma 2a by m. So if the line here, what is the line? Line is in y equal to mx plus c form. If line is given in general form, see now, if the line is lx plus my plus n equal to 0. If the line is lx plus my plus n equal to 0, in this case the condition will be am square equal to ln. This will be the condition when the line is given in the general form lx plus my plus n, and in this case the point of contact is n by l comma minus 2am by l. Yes, this is the point of contact. These things can be obtained similarly. We have already discussed about this. We have seen the derivation. This can be done in the same way. Okay, so for the parabola y square equal to 4ax, if line is given y equal to mx plus c, then the condition of tangency is this, and this is the point of contact. If the line is y equal to mx plus in this form, if the line is lx plus my plus n equal to 0, line is given in general form, this is the condition and this is the point of contact. So these are the two lines in two different forms. Yes. Now I said there are many forms for a parabola. We will see one more form now. X square equal to 4ay. This is the parabola. For this parabola, condition for the line y equal to mx plus c to touch this parabola is c is equal to minus am square. What is the condition? Condition for this line, which line? Y is equal to mx plus c. To touch the parabola x square equal to 4ay. Condition for this line to touch this parabola is c is equal to minus am square. Similarly, if line is given in the general form lx plus my plus n is equal to 0, then the condition will be al square equal to mn. Al square equal to mn. This is the condition. So no confusion. It is enough if you remember at least one formula, either this or this. So see Nana, this parabola x square equal to 4ay will touch the parabola line y equal to mx plus c. Then this is the condition, and in this case the point of contact is what is the point of contact for this? For this point of contact is am comma not am, 2am comma am square. This is the point of contact. If the parabola is touching this line, then this is the condition. In this case, the point of contact is, for this, the point of contact is, what is the point of contact? To 2al by m comma n by em. This is the point of contact. For this one, point of contact is 2am comma am square. For this, point of contact is minus 2al by m comma n by m. So whenever point of contact is required, especially in objective, if you do not remember this, then what to do? Asked point of contact of a parabola and a line, options will be there. You select, you find a option which satisfies both. There will be 4 options. No, take one option, take either curve or line, you verify. If you get only one option, That is the point of contact. If you take a line and if you verify, if you get more than one or proper correct options, they are lying on the line, then you should also verify the curve. Finally, from the options, you select a point which satisfies both. That will be the common point in objective. Yes. Now let us discuss about normal, another concept. Yes. What is the equation of the normal and discussion of normal? So I will take a parabola. Listen. Let y square is equal to 4ax be a parabola. Be a parabola and capital P x1 comma y1. Be a point on it. Be a point on it. See now, rough figure. This is the parabola. We have taken a point capital P x1 y1 on it. So now we need normal. What is normal? This line is tangent. What is this? This line is tangent. What is normal? Normal is a line passing through same point and perpendicular to tangent. This line is what? Normal. Now we will try to find this normal. Okay, what to do? I will take the curve y square is equal to 4ax and I will find dy by dx by differentiating this, which is 2a by y1. So from dy by dx we can find the slope of the tangent. So slope of the tangent at the point x1 comma y1 is, what is slope of the tangent? 2a by y1. This is slope of this line. What about normal? Normal is a line perpendicular to this, no? Therefore the slope of the normal. The slope of the normal at the point x1 comma y1 is perpendicular to this. Therefore its slope will be minus y1 by 2a. So now on the normal we have a point. This point lies on normal also. We have a point and also slope. Therefore the equation of the normal. The equation of the normal at the point x1 comma y1 on the curve is, again using point slope form, y minus y1 equal to m. For this m is minus of y1 by 2a into x minus x1. Therefore you can simplify this, or you can remember this as the formula. In this way you will find the normal. So here you please see, if you multiply this you will be getting xy terms, both mixed terms. This cannot be expressed in the notations. Therefore you remember the procedure. How to find the normal? Point will be there. Just you take the curve, differentiate, get the slope of the tangent. From that, reciprocal with opposite sign will be the slope of the normal. Point slope form, you can find the normal. Okay, now what I do, listen carefully this concept. This is the slope of the normal. I will suppose this is m. I am supposing that slope of the normal is m. Okay. From this, what is y1? y1 is minus 2am. Carefully. This x1, y1 point lies on the curve, no? Therefore, it satisfies the equation. Now I will put y1 here. If I put y1 here, 4a square m square is equal to 4a x1. I can cut 4a and 4a on both sides. Then what will be x1? x1 is am square. Therefore, the point now x1 comma y1 becomes x1 is what? am square and y1 is minus 2am. In this point, what is m? M is the slope of the normal. M is slope of the normal. This is the point on the curve. Therefore, now by taking this point and slope m, I will find the normal. The equation of the normal now. Point slope form again, y minus y1 minus into minus plus equal to m. What is m? This is m. Okay. Into x minus x1. What is x minus x1? x minus am square. Okay. Therefore, I will simplify this as y is equal to what is there? mx. I will write 2am also on the right side. And one more term is there, am's cube. So this is normal. Normal, see this equation. This equation is in terms of only m. What is this? It is in terms of only m. What is m? M is the slope of the normal. So therefore this equation can be taken as equation of a normal in the slope form. This is known as equation of the normal, or simply the normal in the slope form. In the slope form. If generally a point is given, how to find the normal? Using this. Find the slope of the normal. By writing tangent, you can find the slope of the tangent. Tangent is s1 equal to 0. You can write tangent equation from the slope of tangent, then slope of normal, point slope form. If whenever slope of a normal is available, then you can use this. This is no equation of normal in the slope form. This is a normal. Normal means it will be a line like this, perpendicular to tangent. This line is normal in the slope form, and where it is normal? It is normal at the point. Which point? This point. am square comma minus 2am. Yes, this is equation of the normal in the slope form, and this line is normal at this point. So both are important formulas. This is equation of the normal in the slope form, and this line is normal at which point? At this point, am square comma minus 2am. Both should be remembered. They are very, very important in objective. Yes.